the last video, we were seeing about the conditions for maxima and minima in a diffraction pattern. Now, let us draw the intensity distribution curve. The intensity distribution curve is the graph that is drawn between intensity and path difference, intensity and phase difference, or intensity and y, that is the distance from the central maxima. However you want, you can draw. But since this is the path difference, let us write the condition for path difference for. If you write the path difference for a minima, it is, you know that a sine theta is n lambda. So this has to be 1 lambda. This has to be 2 lambda, 3 lambda. Similarly, for the minima, minus lambda, minus 2 lambda, minus 3 lambda, and so on. So this is the intensity distribution curve for a diffraction pattern. Now, since we have completed interference as well as diffraction, come on, tell me what can be the differences between interference and diffraction. When you look at the pattern itself, you can see that this is the intensity distribution curve for diffraction. Similarly, if you consider for an interference, the interference pattern is like this. So when you compare these two patterns itself, you can see that all the fringes are of the same width. All the fringes are of the same width in the case of interference. All the maxima is of the same intensity, whether it is central maxima or any other maxima, all the maxima are of same intensity. But here you can see that the central maxima is the brightest and the intensity goes on decreasing with the order of the maxima on either side. Also, the width of the central maxima is twice the width of the secondary maxima or minima. So what is the width of the central maxima? It is 2 lambda d by a. So what will be the width of the secondary maxima or minima? It has to be lambda d by a. So the width of the central maxima is twice the width of the secondary maxima or minima. So like that, you study the conditions for interference and compare it with diffraction and write down at least 7 differences between interference and diffraction. This is an assignment for you. Write the differences between interference and diffraction after studying the concepts of diffraction. Now here, next we have to see the validity of ray optics. Validity of ray optics, or ray optics is the limiting place of wave optics. Validity of ray optics. What do you mean by saying validity of ray optics? That is, when a light passes through a slit, light can travel either in straight line or it can bend and you can get a diffraction pattern. Both can occur. Suppose if you have a circular slit, if light is passing through the circular slit, if ray optics is valid, then you get some bright circular spot. If you have a linear slit, if light passes through, you get some linear spot in the screen. But if wave optics is valid, light will bend across the edges of the circular slit or the linear slit, whatever may be, and you get a diffraction pattern. Now, we have to discuss up to what distance ray optics is valid, up to what distance wave optics is valid. For that, you just consider a slit. Consider a slit. Let A be the width of this slit. Now, if you have a point source of light over here, and this is the screen over here, suppose if ray optics is valid, this is the limit up to which you get the brightness of this source over here. Beyond this, it is the region of geometrical shadow, isn't it? Now, suppose if wave optics is valid, light will get diffracted. When it gets diffracted, you get some pattern on the screen. So let us consider this is the central maxima you get. And this distance is what is represented by y. You get a diffraction pattern on the screen if the wave gets diffracted. This is the angle of diffraction. Now, up to which distance is ray optics valid? We have to find out. For that, we have a distance which is called as Fresnel's distance. So, what can be Fresnel's distance? Fresnel's distance is the distance at which the spreading of maxima due to diffraction or half the spread of the central maxima becomes equal to the width of the slit. The width of the slit is represented by A, that is at Fresnel's distance. That Fresnel's distance we can represent it by ZF is the Fresnel's distance. At this distance, half the diffraction spread of the central maxima becomes equal to the width of the slit. That distance is called as Fresnel's distance. Now when you see this figure, this distance y and this slit width is not the same. So what we do, we push the slit, you push this screen to the front. When you push the screen to the front, you can see that this y goes on. Here this was y, now this y is decreasing. When I keep the screen over here, y still more decreases. Like that you go on pushing the screen. At one particular distance, you can see that this will be y and this y will be equal to this slit, aperture, width of the aperture. So, at what distance y equal to A is called as the Fresnel's distance. So, at Fresnel's distance, you see that, or up to Fresnel's distance, you can see that ray optics is valid. Because when you push the screen, you are getting a diffraction pattern which is not very much dominant as at the distance D. If you go on pushing the screen over here, the diffraction pattern is observed, but it is not at all prominent on the screen. But at this distance, you don't get a diffraction pattern at all. So at this distance, y equal to A, and at that distance, we call it as Fresnel's distance. So at the Fresnel's distance or up to Fresnel's distance, you say ray optics is valid. Beyond Fresnel's distance, you say that wave optics is valid. We can also define Fresnel's distance as the linear distance travelled by a wave before it gets deviated from its original path. From here only diffraction, that is bending, is taking place. Till this point there is no bending of light, which means till this you say ray optics is valid, beyond this you say wave optics is valid. Now let us calculate what is Fresnel's distance using this formula. Now from this figure you can see that theta is equal to y by d. Now what is the condition for the first secondary minima? Theta is equal to lambda by a. When you at Fresnel's distance, what is happening? At d equal to zf, what happens? Y becomes equal to a. Let us substitute. First of all, let us equate these two. That is y by d equal to lambda by a, and substitute this condition over here. So y is a. So you can write it as a by zf is equal to lambda by a. Or from this expression, lambda into zf will be equal to a squared, or what is zf is equal to a squared by lambda. This is the condition, or this is the expression for the Fresnel's distance. Zf is equal to a squared by lambda. So up till Fresnel's distance, what can we say? Ray optics is valid. Beyond Fresnel's distance, what can we say? Wave optics is valid. So there are two definitions for Fresnel's distance. What is that? It is the distance, linear distance that a ray of light travels before it gets deviated from its original path. It is also the distance at which the half the spread of the central maxima becomes equal to the width of the slit. So remember about the assignment and do it.